Hello everyone. How are you guys doing today? Hi Ahmed and everyone. Assalamu alaikum wa rahmatullahi wa barakatuhu, all of my Muslim students. And hello to everyone. Yeah, Ramadan Mubarak. I can't believe it already started. And I heard in Egypt, some people didn't believe that the moon was sighted. So is also some people here. So this year we have a conflict, and who knows who is correct. But even if we do one extra fasting, we'll get the reward. So it's so nice to see you guys active here in the chat box. Thank you so much. And also thank you so much for being here on time. And overall, thank you for your understanding. I sent you an email last night. Did you guys receive that email? I mean, announcement. Did you see that? We did. Good job. Thank you. So, what I said, if you didn't notice the announcement, I said for the next 1 month, we are going to have Mondays in person and Wednesdays online, only for a month. Okay. And then we will move to both in-person classes. And if nobody has any issue at all in class, then we may keep this Monday in person, Wednesday online. But if that will happen only if nobody has any issue. If somebody wants both in person, I'll be glad to have both in person. So we'll order about that after 1 month, okay? Only for a month, we have this transition in person one day, online one day. So I hope no one minds. And if you don't understand anything at all, or anything, like any tiny thing or anything, whatever you need help with, feel free to come to the office hour on Mondays before class. Okay. And also, as I mentioned in our last class last week, our first exam will be March 9, which is a Monday, and our exam will be from 1.1 to 1.5. If we finish the materials for 1.5 way before our exam, then we'll start chapter 2, but that will not be in the exam. Any questions so far? No question. Okay, now about the homework. I didn't grade your second homework because I have a very important exam to take on this Friday. So I was preparing myself for that. And I'll start grading all the exams, not exams, sorry, all the homework after I'm done with my exam. Rakunjan, question? Comments? Anything? Nothing? I can't hear you if you're talking, Rakunjan. Okay, so about the homework. So if you go to our Brightspace and on the homework tab, you see, let me look at student view. So once you pass the deadline, the homeworks are not visible anymore. So you really have to submit before the deadline. So from your point of view, what you should see is homework 1 and 2, their due dates are over. So all the questions are gone. But we still have homework 3, homework 4, and homework 5. So homework 3 is section 1.3. Usually we put deadline Monday, but this week I put the deadline Wednesday. which is tonight. So if you haven't submitted your homework yet, please submit it before tonight midnight. And then 1.4, I said the deadline will be this week, but then I changed my mind. I said, no problem, just try your best until next week, Tuesday. So 1.4 due date is next week, Tuesday. And since we will not be able to finish 1.5 this week, so our 1.5 homework will be the following week, Tuesday. And then there will be a study here. March 2nd is, let me see, Monday, and then the following Monday, March 9, will be our exam. Now, by the Department of Policy, I'm supposed to give you a review exam, not a exam, sorry, a review homework. So after my exam Friday, I'm going to create a review homework, and I have to put that deadline to March 2nd. So that I have a week to grade those homework. So the review homework, I have to grade every single question by the Department of Policy. So that means I need time to give them back to you before the exam so that you can see how I will grade in the exam. So that means the week on March 2nd, you're going to have two homework. One is section 1.5 and one is review homework. Okay. And also, you see all these departmental suggestions, questions. You don't have to do them. I posted them because some people asked me to, oh, I didn't post it here. Some people asked me to post them to see what department suggests for you to do from the book. But those suggestions is just optional. What you really have to do is whatever I bold out, like do these questions or do that questions. So for 1.4, you have to do 4 main, but in the 4 main, you have 2 more optional. So I think 6. Yeah. 1, 2, 3, 4, 5, 6. 6 questions. Okay. Also, if you didn't know this yet, under the content, we have exam reviews. So if you click on that, I have all the questions you might see. Not all the questions. Most of the questions you might see in the exam from section 1.1 to 1.5. So in this review sheet, what I don't have is short questions. See here, I said there will be true, false, fill in the blank, yes, no type question from logical questions or from the notes I have. So for example, what is a singular matrix? A singular matrix is a matrix which has an inverse, okay? Something like that. Or if you multiply A times B, is it same as multiplying B times A? Those type of question you'll see in the short question. Besides those short questions, so I'll put around 10 points, at least 10 points on the short questions. And the rest of the points will be from everything you see here. And if you missed any class, then you can still revisit all the materials by clicking on the class playlist. All you have to do is click here, and then it will take you to our playlist for whatever you missed. And it's arranged by due dates. So not due dates, the lecture dates. So from 1, 2, 3, 4, 5, 6. Which lecture is today? 7? Yeah. So we are going to have 7th lecture. So after 2 days class, you're going to see 2 days class here. And don't forget to subscribe. In order to subscribe, just click on my name and then subscribe. Okay. Any question, comments, concern? Anything? Nothing? Oh, you're welcome, Ahmed. Thank you for the compliment. Okay, so today we are going to start 1.5, and 1.5 is a little bit different than 1.4 or the other sections. Not too much, just a little different. So in 1.5, we are going to talk about elementary matrices, and then we are going to solve matrix equation, and then we are going to do matrix decomposition using LU decomposition system. So these are the main three things. Oh, and also we are going to learn about finding inverse matrices using raw echelon form. These are the four main things in this section. The inverse is not so important because later in chapter 2, we are going to learn finding inverse in easier way. So if you do not remember, if you do not understand anything here, how to find inverse, just ignore. You don't need that. We have shortcut method for inverse. Okay, so before you go to inverse, first is elementary matrix. In this section, we view the process of solving a linear system of terms, linear system in terms of matrix multiplications rather than raw operations. So if you have a linear system, Ax equals B, where A is the coefficient matrix, X is the variable matrix like XYZ, and B is the constant matrix, then we can multiply both sides of the sequence with some special matrices to obtain an equivalent system in row echelon form. The special matrices we are going to use are called elementary matrices. So we will use them to see how to compute the inverse of a non-singular matrix and also to obtain an important matrix factorization. So what is an elementary matrix? Let's say you have a square matrix and you want to never mind, let me read the definition here. So if you have a square matrix, elementary matrix is a square matrix which you obtain from the identity matrix by applying only one row operation in the identity matrix. On the identity matrix. So we have our identity matrix, and we know all the identity matrix are square: 2 by 2, 3 by 3, 4 by 4, 5 by 5. So let's say you have an identity matrix, and if you apply only one row operation on this identity matrix, then whatever you get, that is the elementary matrix. So what row operation I'm talking about? First of all, we can interchange two rows, and then we can multiply an entire row by a non-zero number, and then we can multiply one row with a number and then add with the other row. These are the three allowed operations we can have in matrix algebra. Now, example. If you look at the first one, okay, so we have a 3 by 3 matrix. So let's start with the 3 by 3 identity matrix. Okay. 3 by 3 identity matrix is 1 0 0 0 1 0 0 0 1. It doesn't matter how you go, row wise or column wise, it's same. Now, if you compare this identity matrix with here, we see that we changed, we swapped first and second row. That means we applied only one operation, and from the list here, this is type 1. We interchanged two rows. So this matrix here, we obtained by applying only one row operation on the identity matrix. So this is an elementary matrix. Now in the second one, if you observe, you see that if you multiply this identity matrix by 3, then it becomes 100, 010, 010, 003. So we obtained our E2 by applying only one operation on the identity matrix. So our E2 is an identity matrix. And what did we do? We did type 2. And then the last one is a little bit harder to see. But if we compare the identity matrix with this one, our second row and third row are same. Second row, third row same. That means we changed only one row, the first row. So we have 100 in the original one, but right now we have 103. Do any of you see what can we do so that 100 turn into 103? Do you see any row operation here? We apply only one row operation. If you don't say it's fine, let me tell you the answer. You have some exercise to do for yourself. So, since we're supposed to have 0 here, but that turned into 3 suddenly, that means we used so we have 100, 010, 001. That means we need to use this number. So if you multiply the third row by 3, and then you add this with the first row. So I1 plus 3 times, well, never mind. R1 plus 3 times R3. What happens? R1 is 100. 3 times R3 is 003. If you add them, you get 103, which is the first column. Sorry, the first row. So the operation we did here to obtain E3 from I3 is I1, means row number 1 in the identity matrix, plus 3 times row number 3 in the identity matrix. And this becomes our E3. And this becomes the first row in the E3. And the rest 2 rows are same as identity matrix. So this E3 is also an elementary matrix. So the main thing, the basic idea, you have to do only one row operation on identity matrix, and whatever you get, that's your elementary matrix. The first 2 easy to see, type 1 and type 2, but type 3 is kind of harder to see. But if you play with the numbers, it will be easier for you to do them. Any question? Okay, now identifying which of these are elementary matrix. Volunteer for A. Do you think A is an elementary matrix? If you do, why? If you don't, why? Any volunteer? Jackie, thank you. Yep, it is an elementary matrix, and it's type 2. Type 2 means you're multiplying one row by a non-zero number. So if you multiply 100, 010, 001, if you multiply the second row by 3, it will turn into 030. So if you compare identity with this A matrix, there's only one change we have. So yep, our A is an elementary matrix. Now volunteer for B. B is easy, right? Come on, guys. Crystal.
It's an example of a type 1 elementary matrix.
Mm-hmm.
because you're swapping row two,
2 and row 3.
row three. Yeah.
Mm-hmm. Our first 100 stays same, and the second and third, they just change. And I see all the answers on the chat box. Good job, guys. You got it. Now the last one. It's harder to see. Little harder to see. Not too hard. Any guess? Rayat.
Oh, I said it's not like it's not an elementary matrix because
Why not?
it's let's say if you try to do a type two on
Mhm.
this, it won't work
So we
because
have type 1 means change two rows, type 2 means multiply by a non-zero number, and type 3 means multiply one row by a non-zero number and add with that another row.
yeah. So I just thought of like type two because you can't multiply two by zero and still get two in this case. So that's
True,
why. Yeah.
but first tell me the identity matrix for 2 by 2.
Oh,
What
it's
is I2?
it's gonna be 1 0 and then 0 1.
Mm-hmm. Now compare this with C.
Yeah, it's not gonna work because if you try to do two times row two, you're not gonna get the second row for the original matrix, which is 200.
Exactly. So
Yeah,
what else you can think of?
you could.
How can you make this 0 into 2? You need help from someone, right?
Uh,
It definitely cannot be type 2 because 0 multiplied by anything is 0. And also it's not type 1 because you did not swap the two rows. So if it's an elementary matrix, it has to be type 3. Means multiply one row by a non-zero number and add with another row. So what do you think?
uh, so you could just so you just multiply the first one by two.
Mm-hmm. So row 1, 2 times row 1, and then
So you do two times row one,
mhm,
uh, plus
plus
plus row two.
plus row 2. So 2 times row 1 is 2, 0, plus row 2 is 0, 1. If you add them, you get 2, 1, which is our second row. So yep,
Oh,
it is an elementary matrix, and this is type 3. So type 3 is hard to see. Even for me, I don't see it directly. I have to think. So R2 in the C is 2R1 plus R2 from the identity matrix. Any question? Okay, now 3 more. Volunteer for D. This should be easy to see. Just compare all of these with 1, 0, 0, 0, 1, 0, 0, 0, 1. What can you do, or can you do anything on this matrix and they will turn into D or E or F? So any volunteer for D? If you don't volunteer, then I'm going to call you out. How's that? Okay. Soraya, good job. Thank you. Go ahead.
Um, I'm gonna say no because it has a zero row and
Good job. There
it's
is
not
no
elementary.
number you can multiply your third row by and it will turn into 0. It's impossible. Perfect. Now for next one, E. Volunteer. Okay, so Chris Ahmed, your name is first on the list. Daniel is asking, we use the type of operations to turn them into identity matrix. The other way around. You start with the identity matrix, and then you apply type 1, 2, or 3, and then you'll see whatever you get, that's the elementary matrix. So E is type 3. So remember, elementary matrices are those matrices which has only one step away from identity matrix. Only one step. How many things you see in E that are different than I, the identity matrix? 2. So can E be an elementary matrix? No, because we cannot do 2 operations at one time. We are allowed to do only 1 operation. But E needs 2 operations. One is here, this 1 turn into 2. At the same time, this positive 1 turns into negative 1. So if you want to get E from identity matrix, you have to do 2 operations at the same time, which is not allowed. So no, more than 1 operation is not allowed. I should write this down. More than 1 row operation is not allowed. Now the last one, the easiest one here. You don't need to use your brain to answer this. Good job, Christelle and Daniel, everyone. It is not, because it's not square. Identity matrix square, so the elementary matrix has to be square matrix. So if you don't have a square matrix, they're automatically not elementary matrix. So, good job, guys. Here are all the answers for all 6 questions. And now you may wonder why we are learning about these elementary matrices. Why do we care? Well, we care because they're going to actually help us to find our inverse. So there's a theorem. It says if E is an elementary matrix, then E is non-singular. Means it definitely has an inverse. And that inverse is an elementary matrix of the same type as your elementary matrix. For example, if let's say you have E1, which is type 1, means you only swap 2 rows of identity matrix. That means the E inverse you're going to have will also be type 1. Let's say you have another matrix, E2, and this matrix is type 2, means we multiplied 1 row by a non-zero number. That means its inverse, E2 inverse, will also be a type 2 matrix. And same thing for E3, means multiply 1 row by a non-zero number and add that with another row. So whatever operation you apply on the identity to get your matrix, when you find the inverse, that will be the same thing, that will have the same operation as your elementary matrix. Now that takes us to equivalent matrices. So before, in which section I forgot, 1.2 or 1.3, in some section, we said 2 matrices are equal if all the elements are same. So equal and equivalent, they are not same. Equal means they're exactly same. If we have 1, 2, 3, 4 in one matrix, let's say A, then in B matrix, you have to have the exact same 1, 2, 3, 4. So they're equal. Now for equivalent, they don't have to have the exact same elements. Two matrices are equivalent if you multiply them by same elementary matrix. That's the concept. So here the book said, if you have any system of equations, Ax equals B, we can obtain an equivalent expression of the same thing if you multiply both sides of your equal sign by the same matrix on the same position. So if you have Ax equals B, so remember, A is the coefficient, X is the variable, and B is the constant matrix. So if you have, let's say, 2x plus y equals 5 and x minus 3y equals 6, this can be written as 2, 1, 1, negative 3. So this is your coefficient matrix. There are two variables you have, x and y. And our B matrix, which is constant, is 5 and 6. So every system of equations can be rewritten as Ax equals B. Now, if you want to solve this variable matrix, then you need to get rid of your A. So if you want to get rid of the A, you need to multiply both sides of the equal sign by the same matrix. So whatever matrix you're multiplying by here, you need to multiply by the same matrix on the other side on the same position. So you need to multiply the left side of A. Same thing, you need to multiply the left side of B with the same matrix if you want to get this X alone. So they're saying, what's you're multiplying by M, which is any matrix, and then whatever you get, you have the same equivalent system. You're going to get the same solution. So these two matrix operations, these two equations are equivalent. They're not same, but they're equivalent. And even though they're equivalent, but their solution is supposed to be the same. So here it says Ax equals B is same as a hat times x equals b hat. What does that mean? If you compare A with A hat, this A hat is a matrix multiplied to A on the left side. And if you compare B with B hat, this B hat is the same matrix B, but you multiply by elementary matrix on the left side. So elementary matrix gives us equivalent expression, or even if they are not elementary matrix, you still get equivalent matrices. So equivalent equations. What do you call equivalent equations? If you multiply by same matrix on both sides of the equal sign. Yeah. So we have several types of equivalency. One is row equivalent, another is column equivalent, and then probably we have more, I don't remember. So here, we're not going to go into details, just introducing you what is row equivalent. A matrix B is row equivalent to matrix A. So you have a matrix B. Let me change the color. You have a matrix B and you have a matrix A. Now, obviously they are different from one another because they have different names, and we are going to take them as different. We're going to take different elements in them. But we can say these will be equivalent if there exists a finite set or a finite sequence of elementary matrices, E1 to whatever E we need. And if you multiply all those matrices by either A or B, and you get the other one. For example, if you multiply E1 times E2 times E3 up to whatever many you need, if you multiply B and you get A, then B is an equivalent to A. Or if you want to go to the other way around, you can multiply E1 times E2 times E3, and then whatever many you need, multiply all of them by A. And if you get the B matrix back, that means A is equivalent to B. So if A is equivalent to B, obviously B has to be equivalent to A. So in other words, if you multiply one matrix by a series of equivalent matrices and you get another matrix back, then the two matrices you started with, they are equivalent. They are row equivalent. We're not going to go into column equivalent, just introducing you to the row equivalent. And they have a good thing, a good transition. Let's say three matrices, A, B, and C. So if you know A is equivalent to B, and then B is equivalent to C, then you can say A is also equivalent to C. Or if A is equivalent to B, then B also has to be equivalent to A. So it goes both ways. The direction is two-way. If A is equivalent to B, B is equivalent to A. Then if three things are equivalent to one another, that means the first one has to be equivalent to the last one. Now, all these things we talk about just because we want to use them to find the inverse matrix. Now, how do you find? No, inverse matrix comes later. Before finding inverse matrix, we are finding elementary matrices. So given the given the square matrix A, to find its elementary matrix or matrices, to convert it into another matrix B, write the equation as A and then I next to that, and convert this into E, and then whatever you get, that will turn into elementary matrix. For example, let's say you have a 2 by 2 matrix. You write this down next to the identity matrix. And then you apply row operation. Type 1, type 2, type 3, whatever you need. Once you convert this, then you are going to get B matrix here. So your goal is to convert your A matrix into B matrix. So whatever operation you need to do, you apply them. And then whatever you get, that's your elementary matrix. So here it will be, I think, a product of many elementary matrices if you don't start with INT matrix. We're not going to do this in class, okay? This is just background information. We don't need this for now. But there are some fun examples. We have two matrices A and B, and they want us to find an elementary matrix E. So that if you multiply this A by E, it will turn into this B matrix. So what you have to do is you have to look at, you have to compare them. And then whatever is not same, you have to see which row operation or which row operations going to give you from A to B. We're going to apply those into INT matrix. So for example, if you look at the second row, we have 5, 3 in A, 5, 3 in B. So our second row is same. We don't have to worry about that. Now, if you look at the first row, in first row in A is 2, -1. First row in B is -4, 2. What can you do in A so that it will turn into B? Which row operation you need to apply to make this conversion? Multiply by -2. So you multiply this by -2, but not here. What you're going to do is we are going to take identity matrix. 1, 0, 0, 1. and you're going to multiply this first row by -2. That's going to give us the elementary matrix E they're asking for. So 1 times -2 is -2, 0. And then we don't have anything for 0, 1. So this is the elementary matrix. You may wonder, what is this? Like, why do we care? What is this? Well, look at the cool things. Remember I said, if you multiply A by E, you're supposed to get B. So let's see, if you multiply A by E, what do you get? EA means -2, 0, 0, 1, multiplying by 2, -1, 5, 3. So let's do the multiplication. You take one row from the left matrix and you multiply every column 1 by 1. So when you do first column, we get -2 times 2, which is -4, plus 0 times 5, which is 0. And then we go to the second column to multiply. -2 times -1 is +2, and then 2 times 3 is 0, so we don't have to add anything. And then we go to the next row and do the same thing. We multiply the first column. 0 times 2 is 0, plus 5 times 1 is 5. So we get 5 here. And then you multiply the second column with the second row. 0 times -1 is 0, so you're left with 3 times 1, which is 3. Now if you compare this with that, this is our B matrix. So we can convert A into B if you multiply by this elementary matrix, -2, 0, 0, 1. Okay. Any questions so far? Would you like to try this one? Convert A into B. So find which elementary matrix you need here to convert A to B. Type 1. Okay, let's see. Let's compare the two of them. 2, 1, 3, 2, 1, 3, same. And then we have -2, 4, 5 here, but -2, 4, 5 there. We have 3, 1, 4 the third row, but we have 3, 1, 4 as the second row. So yep, we are going to swap row 2 with row 3. So identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. The operation here we have is swapping row 2 with row 3. So the elementary matrix they're asking us to find is 1, 0, 0, 0, 0, 1, and then 0, 1, 0. Because we swapped these two from the original identity matrix. You got it. I see that. Good job. Now the last one. Try it and let me take your attendance. Okay, so today is 2/18. Ahmed, are you still there? Okay. Crystal,
I'm here.
Good. Christian?
I'm here.
Okay. Danielle? Yeah. Eric?
I'm here.
Good job. Florence? Okay. Franklin?
Here.
Perfect. Gashan or Gasan? No. Halil?
Here.
Imran?
Here.
Jackie, are you still there? Jackie?
I'm here.
Okay. And Jerry? Okay. Jonathan? One? Okay. Julian?
I'm here.
Great. Karma?
Here.
Kate?
Here.
Man?
Here.
Kathy? Okay. Matthew? Okay. Melissa?
Here.
Mohammed?
Here.
Muntaha? Omar? Omar C? Omar D? Prabhat?
Here.
Ratmanjan?
Here.
Rayat, are you still there?
Yeah, I'm here.
Okay. Sadia Sattar? Sadia Sattar? How about Sadia Sheikh? Are you guys not here? Samuel? Sam? Yeah. Soraya, are you still there?
I'm here.
I guess that is here. Okay, Soraya, I got you. Saima? Yeah. Stephanie?
Here.
Valerie?
Here.
Okay, so Sadia Sheikh, are you there? No. Okay. The two absent. Gashan Jalasi and Sadia Sheikh. Where are you guys? In our classroom or in different places? Is anybody in our classroom?
Yeah, I'm in the class right now.
Okay, good. The other classroom, they're waiting for us to be online. So they didn't come to our classroom today.
Nobody said anything.
Okay. I told them we'd be online today, last week. So probably they forgot. Or maybe the room is cooler now.
Yeah, it is cooler.
Oh, that's why they didn't come. Okay, so who got it? I saw someone got it. Let me see. Rayat. So Rayat says R3 is negative 2 R2 plus R3. So let's see. R3. So we take R3 negative 2. Sorry, 2 times R1. 2 times R2. Come on. Negative 2.
My bad.
You got the same thing,
Positive
but
2.
positive. Did I make a mistake? Okay, we'll see. Positive, right? Okay. So 2 times R2. This is our R2. If you multiply by 2, we get 204. And then this is our R3, negative 2, 3, 1. If you add, we get 0, 3, 5, which is same as this one. Good job. So you got the raw operation correct. Oops. The first row are same in both. Second rows are same in both. And the third row we just invented or identified our operation. That means you're going to apply that operation in your identity matrix. So identity is 1, 0, 0, 0, 1, 0, 0, 0, 1. And if we apply 2 R1, R3, what is this? Today my writing is so bad because I don't know what happened to my hands. R3 is 2 R2 plus R3. If you apply this operation, who can tell me the E matrix for this?
It's 1 0 0
Mm-hmm.
0 1 0
Mm-hmm.
and 0 2 1.
0, 2, 1. Perfect. So this is our elementary matrix. If you multiply E with A, you're supposed to get the B matrix. I'm not going to do the multiplication, but you can verify that. So this is easy, right? I mean, not too easy, but kind of easy. What do you think? I may give this in the exam if I have enough space in the exam. At least one, that's my plan, at least one. Find elementary matrix so that if you multiply A by elementary matrix, it turns into B. So all you have to do is figure out what's the difference between the two matrices, apply that into identity matrix. Any question so far? No question? Okay, then the next thing. Theorem of equivalent conditions for non-singularity. Remember, non-singular means it's a good thing. Non-singular means it has an inverse. Singular means bad. It doesn't have inverse. So non-singular is good. If you don't remember, you can think of this way. If you're single, you don't have anybody. No BF, no GF, so you're single, you can spoil, you can go bad anytime. But if you are non-single, means you do have someone. So what do you have? For matrix, it has an inverse. So it cannot go bad. So non-singular means not single, and since it's not single, it has an inverse. Okay? Now, A is a square matrix. Then all three things here are equivalent. Means one is equal to other one. So if A is non-singular, means if A has an inverse, then you can solve the homogeneous system of equations x equals 0, and it will have only the trivial solutions 0. Means all the variables you're going to have, they all will be 0. x1 is 0, x2 is 0, x3 is 0. And this A matrix here, you have the constant matrix is row equivalent to the identity matrix. So if you have a matrix that is row equivalent to identity matrix, it has an inverse. And also, if you try to solve the homogeneous system of equations, means if constant matrix is 0, then all the variable must be 0. Okay. A corollary that goes with this theorem says the system AX equals B of n linear equations in n unknown has unique solution if and only if A has an inverse. For example, if A is a square matrix and it has an inverse, then the system of equations you have, they're going to have unique solutions. Means if X, I hate this. If X, can I write on the next page? Let me save this. What I was saying means X will have one number, Y will have one number, Z will have one number. In other words, all the system of equations you have, they're going to meet at one point at most. So, what's the closing? So this is true only if you have a square matrix that has an inverse. If it doesn't have an inverse, then it's not true. And now that leads us to the next important topic. Well, how do we find inverse? If we know that if a square matrix is an inverse, we're going to have a unique solution, then tell us how to find that inverse. That's our next topic. So finding inverse of a square matrix, only square matrix can have inverse, okay? If you have non-square matrix, it cannot have inverse. So there are several ways we actually can find inverse depending on which dimension you are in. If you have 2 by 2, then there are two methods. One is shortcut and one is this reduced echelon form. And if we have 3 by 3, there are many ways of finding it. But in this class, we're going to learn the reduced echelon form method, and there is one shortcut method. Actually, we're going to learn 3 methods. One very, very shortcut, one called cofactor expansion, and one called the reduced echelon form. My favorite one is the shortcut one. That I'm going to teach you in chapter 2. Now here, we have to learn how to find the inverse using reduced echelon form. So we are going to use the same concept what to use to find the elementary matrix. You're going to write I next to the A matrix, and then your goal is to convert this A matrix into I. So whatever operation you need to do, apply all those operations so that A matrix turn into I matrix. And then in this process, once you're done converting A into I, this I matrix you have here next to the A will turn into a new type of matrix. That matrix will be the inverse matrix. It's a troublesome method, but we have to learn it. So let me actually restart this. I don't know why it happens. In the middle of the class, ink doesn't get saved. So weird. Refresh. Come on. Okay, so let's do an example. Oh, and here the important note says, in this process of converting A into identity matrix, if you have one entire row filled with zeros, that means the inverse doesn't exist. The inverse matrix cannot have an entire row or entire column filled with 0. So, what is our goal? First, start with the goal. We are given A, which is 101 row-wise, 334 row-wise, 223 row-wise. Our goal is to convert this into 100, 010, 001. That's our goal. Convert this into identity. And then apply all the operations, 3 allowed operations. You can apply any of them or all of them to do that. Now, how do you start? We write A, and then with a bar, we write down the identity. 100, 010, 001. And then eventually at the end, after we convert this A into this I, we are going to have a new matrix here. We don't know the matrix yet, but whatever we're going to have here, that is the inverse we are looking for. So let's do this real quick. Let's compare. We have 1 here and we have 1 here. So we are happy. We don't have to change this one. Then we have 3 here, but we want to have 0 here. So our goal is to convert 3 into 0. That means we need to change row 2. So what can you do so that this row 2, the number 3, will turn into 0? Any idea? Row 2 minus 3 row 1. Yep, we can do that. And also at the same time, we have 2 here, but we want to have 0 here. So goal is to convert 2 into 0. So we need to change row 3. So what can you do? Row 2, and then we can do minus twice row 1. So if you do that, our 132 column will turn into 100 column. Now let's do the math on the side. Row 2 is 334,010. And if you multiply the entire first row by 3, you get 303,300. Negative. If we add these two, we get 0, 3, 4 minus 3 is 1, 0 minus 3 is negative 3, 1 minus 0 is 1, and then 0. So this will be our new second row. Same thing for third row. Sorry, this is row 3. We have row 3 is 2, 2, 3, 0, 0, 1. And we are subtracting 2 times row 1. So negative 2 times 1 is negative 2, 0, negative 2, negative 2, 0, 0. When we add, we get 0, 2, 1, negative 2, 0, 1. So we get 1, 0, 1, 1, 0, 0, 0, 3, 1, negative 3, 1, 0, and then 0, 2, 1, negative 2, 0, 1. At least our first column is correct. Now, if you compare that with the identity matrix, we need to go more. Uh, did I make a mistake anywhere? I did. I can tell. This should be 0. Because 1 times... Oh, no. It's not a first row. Come on. No, sorry, I didn't make a mistake. 3, 3, 4. And then we have 0, 1, 0. Then we multiply first 1 by -3. So -3, 0, -3. -3, 0, 0. So 0, 3, 1, -3, 1, 0. Okay. Are we going to have fraction? I hate fraction. 0, 3, 1, -3, 1, 0. Okay. Let's make this into 0 because identity matrix has 0 here. And also at the same time, we can make this 0 yeah. So we need to change row 2 and row 3. What can you do? How can we change 1 into 0 in row 3, in row 2? Which row we are going to need help from? Row 1 or row 3? We can do row 3 minus row 2. Sorry, other way around. Row 2 minus row 3. So what happens? We have 0, 3, 1, -3, 1, 0. And we have 0, 2, 1, -2, 0, 1. If we subtract, all this sign will change. We get 0, 3 minus 2 is 1, 1 minus 1 is 0, -3 plus 2 is -1, 1, -1. So this will be our new row 2. And then row 3 here. Or let's do one at a time. I think it will be easier. So we have 1, 1, 0, 1, 1, 0, 0, 0. Our new row 2 is 0, 1, 0, -1, 1, -1. And let's keep this 0, 2, 1, -2, 0, 1. Okay, and now we can change this into 0 easily. So I need to change row 2. Which operation we can do to change this 2 into 0? Any idea? Come on, guys. If I do everything myself, it's annoying. Franklin, row 3 minus 2 row 2. Perfect. So let's do the operation here. Our row 3 is 0, 2, 1, -2, 0, 1. And multiplying by 2, row 2. So 0, negative 2, 0, negative, negative become positive 2, negative 2, and positive 2. When we add, we get 0, 0, 1, 0, negative 2, 3. Okay, let's write this down and see what happens now. We have 1, 0, 1, 1, 0, 0, 0, 1, 0, negative 1, 1, negative 1, and we get 0, 0, 1, 0, negative 2, 3. We're almost done, almost. Now there is only one element that we don't want, is this one. What can you do so that this one will turn into 0? So we need to change our row 1. So it will be current row 1 minus row 3. Good job. And this time I don't need to write this down. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus negative 2 is 2. 0 minus 3 is negative 3. And then the rest are same. 0, 1, 0, minus 1, 1, minus 1, 0, 0, 1, 0, negative 2, 3. So if I didn't make any mistake, then our A inverse is 1, negative 1, 0, 2, 1, negative 2, negative 3, negative 1, positive 3. So once you have your identity matrix on the left, this is your I. Next to the I, whatever we have, that's the inverse. Now, if you don't know, like I'm not sure, right, if it's correct or not. Is there any way you know that I can verify my answer? Is it correct or not? Answer in 2 seconds. Who can answer in 2 seconds? How can I verify whether this answer is correct or not? Nobody remembers? I should ask this in the exam. How to verify inverse is correct or not? If you multiply anything by identity matrix, you get the same matrix back. But you're on the right track. It has something to do with I. The thing is, if you multiply A with A inverse, you're supposed to get what back? Identity. So let's multiply it real quick since I don't have time. My A matrix. 1, 3, 2. Here. 1, 3, 2. And then we have 0, 3, 2. And then 1, 4, 3. Multiply this with the inverse we just found. 1, 2, negative 3, negative 1, 1, negative 1, 0, negative 2, 3. All of them are row-wise. And let me just verify one thing. One column or one row. One row. We take 1, 0, 1 and you multiply each of these columns individually. And let's see what do you get on the first one. So real quick, 1 times 1 is 1. 0 is gone, and then 1 times 0 is gone, so we have 1. 1 times 2 is 2, and then 0. And then 1 times negative 2 is negative 2. So 2 minus 2 is 0. And then 1 times negative 3 is negative 3. 0 is gone, and then 1 times 3 is positive 3, so you get 0. So at least my first row is correct. And you can check the other ones. Take the second row and multiply each column. You're supposed to get second row in the result. And if you take the third row and multiply each column, you're supposed to get the third one back. And that has to give you identity. If not, then you are wrong. If you get identity, then our answer is correct. So, in our next class, which is Monday in person, we are going to learn about solving matrix equation, and then we are going to go to matrix decomposition. So maybe we'll be able to finish our 1.5 next week. Yeah, most likely. Probably Monday, or probably we need also Wednesday. But yeah, we can finish 1.5 next week. So let me see that date again. I said the due date for 1.5 was March. Yep. You can finish your homework by March 2nd. Okay, so that's all for today. Any question? Any comments? Concern? Complaint? Yes, exam is from 1.1 to 1.5.
Thank you, Professor. Have a good day.
Thank you. You guys also have a very wonderful day.
Great.
And happy
Thank you.
Ramadan.
Happy Ramadan, you too.
Thank you. And if you have any question, email me anytime. Rahman John, go ahead.
Hello, Professor. Ramadan Mubarak. I would like to ask you, can I submit the homework maybe by tomorrow, if it's okay with you? On
What are you
hello.
talking about? Which one are you
I'm
talking
talking
about?
I'm talking about homework 3 that is due today, February 18th.